Hey class, so let's look at a couple of examples looking at these two-body problems. One just being a couple objects on a pulley, and they're pulling on each other. A second where we have an object that's on an actual surface, such as a table, and there's another object attached to it that's coming down as well. So let's look at these two examples, and then we'll have one more video looking at a couple of examples that basically will finish the worksheet that I've already given out for this week. So in this example, I might head out a frame a couple times. I'm going to keep talking though, just so I get the words in here. So I'm going to head out a frame. But let's talk about this question. We have a mass of 7 kilograms here, a mass of 10 kilograms, and all we're trying to figure out is just our acceleration. So I like to put down like object 1, object 2 on these things. That way we can kind of like find force of gravity 1, find force of gravity 2. So I'm just going to put like object 1, object 2. So let's find the force of gravity kind of 1, and force of gravity 2. Okay, so how are we going to do that? I'll try and stay in frame as much as possible. Again, we have gravity that is just 9.8, so gravity is going to pull on everything the same. So let's find the force of gravity on each one of these. We have force of gravity here, 10 times 9.8 gives us 98 newtons. Force of gravity 2, 7 times 9.8 gives me 68.6 newtons. And so there's our two forces of gravity. So all I need to do now is find a net force, then turn that into an acceleration as well. So let's do net force here. I'm going to put it up here, that way I'm a little more in frame. Net force. Again, this is kind of like the question where we have two people pulling in opposite directions. This is two objects pulling in opposite directions. So we're just going to subtract them to find the net force. 98 minus 68.6 gives us a net force of 20.6. So 20.6 newtons is our net force. And lastly, to find acceleration, which I'll do right here, we're going to take that net force and we're going to divide it by mass total. Okay, that is the big change kind of from this two-body, multi-body. All the masses have to go together to get a mass total. So when I add these, I'm just going to put down mass M total, T-O-T, is 17 kilograms. I'm just going to write that down here. All right, so that is the mass that you're going to divide your net force by. So we have a net force, we have our mass total, so let's do this. Acceleration, just we're going to put our force net on top, and now this will be mass total on the bottom. So I go 20.6 divided by 17, and I get an answer of, I put it on my sheet here, 1.73. So 1.73 meters per second squared. So there's your answer for this question. No, this question is not exactly the same as the one from your worksheet. It has different numbers, but to answer it, the actual, like to find the solution, the same steps are going to be exactly the same. So this one's very similar to, I think, question like 1 and 2 on your worksheet. On your worksheet, when it gives, like some of the questions give 3 kilograms, 5 kilograms, and then some of them say like 1m or 5m. What that means is like that has a mass of 1 and a mass of 5. I don't know why it kind of changed. I took this worksheet off a really good pre-university website, like one that a teacher that I went to university and took his class. He had some really, really good two-body problems. So I went back, I took some of them. So this is his pre-university work. So yeah, that's where I got it from. So, but some of them say like 1m and 5m. Honestly, just consider them as 1 kilogram, 5 kilogram, and you're all good. It'll work the same. All right, example number 2. 7. So I'm going to keep the same masses here. I'll just show you how this question changes. So we have 7 kilograms on the actual table now, and 10 kilograms down. I still like to label them like object 1, object 2, so I'll still keep this object 1, object 2. So let's go over here now and find. Well, we have force of gravity on 1, which is 98. That doesn't change. And force of gravity 2, which is still 68.6. That doesn't change. Okay, but the thing is, this force of gravity now is not going to be pulling on this because the table's doing the opposite work. There's a table that's doing work on this mass. So there is a force normal. I'm going to put a 2 there because that's talking about object 2. Sorry there's a little glare there, but it says force normal 2. And that's because this object has a force normal. This does not. It's not on anything. So force normal 2 is exactly the same, 68.6. Okay? Again, there's no angles here. It's just straight up and down. Okay? This object's not being pulled in an angle. It's being pulled straight sideways. And it's not on an angle, so it's exactly the same. So force normal is exactly the same as force of gravity for that second object. So what we can find for this object is we can find a force of friction. We have our mu there, our coefficient of friction. Force of friction is going to be 68.6 times 0.3. Okay, when I do that, I have my answer over here of 20.6. 20.6. And I'm going to draw that into this actual problem to show you guys here. So that would be this force right here. Force of friction would be 20.6. And again, we're taking our force normal, which is the same as force of gravity in this one, and just times by that coefficient of friction. Again, just exactly like we would have done like 3 weeks ago. We were just talking about simple friction problems. We're bringing simple friction back into this problem right now. All right, we have our force of gravity right here that I can draw in. Force of gravity, 1 is 98. So these are the two forces that are interacting on this question. Force of gravity 1, force of friction over here. So let's find our net force. Net force. F net equals 98 minus 20.6, which gives me 77.4. 77.4. Lastly, let's actually find our acceleration right up here. We're going to take that net force and again divide it by mass total. 77.4 divided by, I get to add these two up, 10 and 7, 17. And I get an actual final answer of 4.6. I rounded up, I think it was like 4.659, but 4.6 meters per second squared. There is your final answer of how fast this whole thing would go on. Not just this object. This object would as well be moving at 4.6 this way. This would be going down at 4.6 because they're connected. All right, thanks class. I'll have one more video talking about if we have a little multi-step, basically explaining the last couple questions of the worksheet for you. All right, thanks class.